Welcome to my series on cloud. Today, we're diving deep into the Virtual Private Cloud, or VPC for short. VPC is a logically isolated section within a public cloud environment. It provides a virtualized network infrastructure, giving users the ability to define and control the networking environment, including IP address ranges, subnets, route tables, and gateways. It's crucial because it provides a secure environment for your cloud resources. At its core, a VPC offers isolation from other virtual networks on the cloud platform. In the context of a VPC, isolation ensures that the resources and data within one VPC remain separate and inaccessible from those in another VPC. A VPC inherently acts as a security boundary in the cloud. Everything inside this boundary is considered trusted, while entities outside this boundary are untrusted unless explicitly permitted. Human errors, like misconfigurations, are common in IT. In a non-isolated environment, such a misstep in one section could expose vulnerabilities across the entire network. However, with VPC's isolation, the blast radius of such errors is contained. If a security incident does occur, having isolated VPCs makes incident response more manageable. When creating a VPC, users need to specify an IPv4 CIDR, classless interdomain routing, block for the VPC, which represents the IP address range for the network. Once a VPC is defined with an IP address range, this range can be further divided into subnets, with each subnet having its distinct CIDR block. The addresses within a VPC are referred to as private because they are not directly routable on the public internet. They are reserved for private networks and allow devices within the VPC to communicate with each other without exposing the traffic to the external world. A VPC can be segmented into multiple subnets, allowing finer control over the IP address ranges and facilitating better organization and security. Each subnet can be associated with different availability zones for redundancy and high availability. Route tables within the VPC determine the path of the internal traffic, directing it based on the destination IP address. A route table contains a set of rules, called routes, that dictate how traffic should be directed within a network. Each route in the table specifies a destination and a target. The destination is typically an IP address range, and the target determines where the traffic will be routed. When a resource, like a virtual machine, within the VPC wants to send a packet to an IP address, the route table is consulted. The route table checks each route to find a match for the destination IP address. Once a matching route is found, the packet is sent to the specified target. By default, every VPC has a main route table. If a subnet doesn't have an explicitly associated route table, it uses the main table. Move to next topic, which is internet connectivity. While a VPC provides isolation, it can be connected to the internet using an internet gateway. An internet gateway is a horizontally scalable, redundant, and highly available VPC component that allows communication between resources in the VPC and the internet. Continue with access control. Security groups and network access control lists work at the instance and subnet level, respectively, to control inbound and outbound traffic to resources within the VPC. They function as virtual firewalls, ensuring only permitted traffic enters or exits the VPC. You can specify rules based on protocol, port number, and source/destination IP address or CIDR block. For example, you might allow incoming HTTP traffic from any IP address but restrict SSH access to a specific IP. By default, security groups allow all outbound traffic and deny all inbound traffic. Network Access Control List provides a higher level of control and acts as a firewall for controlling traffic in and out of one or more subnets. Rules and Network Access Control Lists are evaluated in order, starting from the lowest numbered rule. Once a rule matches the traffic, it's applied regardless of any higher numbered rule that might contradict it. For instance, if rule number of 100 allows traffic from IPX and rule number of 200 denies traffic from IPX, the traffic will be allowed because rule number 100 is evaluated first. While security groups operate at the instance level, network access control lists operate at the subnet level. It's not uncommon to use both security groups and network access control lists together. They can complement each other, with network access control lists providing a broader first line of defense, and security groups offering a more granular, instance-specific set of rules. Finally, we'll look at connectivity to on-premises. For hybrid cloud architectures, a VPC can be connected to an on-premises data center using virtual private network connections. A VPN establishes a secure tunnel over the public internet, allowing data to flow between your on-premises data center and your VPC in the cloud. It uses encryption and other security mechanisms to ensure that only authorized users can access the network and that the data cannot be intercepted. But for businesses that require a more consistent, high bandwidth, and ultra-reliable connection, cloud providers offer dedicated network connections. AWS Direct Connect and Azure ExpressRoute are prime examples. Instead of routing traffic over the public internet, these connections provide a direct link between your on-premises setup and the cloud. In essence, a VPC offers a sandboxed environment within the public cloud, granting users the flexibility and control of a private data center but with the scalability and features of a cloud platform.